Welcome to our second review day before the test. Remember, this is not on your calendar, so make sure, I should say the homework's not on the calendar, so make sure to write it down somewhere on the calendar or write in your planner. For tonight's homework, you're going to be doing numbers 3 and 9 on a separate sheet of paper. And you also need to bring your Chromebook to class. Next class, it needs to be charged, so make sure to charge it tonight. We'll be working individually on our Chromebooks on a Jamboard tomorrow, so we'll need to have that. All right, so for our first homework proof, we had number 1. There was only one way to do this proof. So it didn't matter if you did midpoint first or the perpendicular line stuff first. I chose to do midpoint first, so I had midpoint implies 2 congruent segments. If D is right in the middle of BC, that means BD is congruent to DC. We also had, I should mention, a given that was congruent, so I already had that marked up in my picture, AB and EC. So at that point, I had two sides, so then I did perpendicular lines imply right angles. The right angles are coming from the perpendicular lines with meet at B and C, so I said angle B and C are a right angle. You could use 3 letters there, or you could have numbered them, that's fine as well. And then automatically next we need to do right angles implies congruent angles. Our statement angle B congruent to angle C. We now have an angle in between two sides, so that's side angle side, and our statement is what we wanted to prove. For our basic rigid motion, we needed to reflect one of our triangles. I chose triangle ABD over the perpendicular bisector. Oops, and actually this shouldn't say BD, this should say BC. And you also could have said AE, and that's fine as well, but over the perpendicular bisector of BC. Moving over to number 8, there was 2 ways that you could do number 8. Everybody should have had midpoint implies 2 congruent segments to get the NQ and PQ are congruent. So that should be in everyone's proof. And then I'm going to show you the 2 different options. The quicker way is to then just do a reflexive property, get MQ congruent to NQ, and then you have side, side, side congruent to side, side, side. Now the other way you could do it, because MN and MP are 2 congruent sides in the big triangle, we could say 2 congruent sides implies isosceles triangle, so triangle PMN is isosceles. And then we can use isosceles triangle implies 2 congruent base angles. The base angles are those that are across from the sides that are congruent, so angle P and angle N. You could have used 3 letters for those, or you could have numbered them. And then that would have given us an angle in between 2 sets of sides, we would have had side angle side. Sometimes there will be more than one way you can do a proof. Sometimes there'll only be one way. Then our basic rigid motion, we're just reflecting one of the triangles over MQ. So in class today is going to be very similar to last class. We're going to do 2 proofs together, and then we will have you study your reasons card until you've got them all the way down. And then once you are able to get all the way through them correctly, then you'll be able to start your 2 homework ones, which are 3 and 9, on a separate sheet of paper. These questions are on page 35 and 36 in the packet, but we will need our separate sheet of paper, and we're going to be starting with number 4. So we'll give you a minute to get that separate sheet of paper out, and also be over on page 35. And again, we're going to look at question 4 to start out. And then once you have your separate sheet of paper, go ahead and start doing your statements, reasons, and givens. All right, nothing was congruent in our givens. So we can go ahead and get going. We got an isosceles triangle first, so let's maybe do our isosceles triangle stuff. So we have isosceles triangle implies, and we've got two different options. We could do either our two congruent sides or two congruent base angles. We'll end up doing both in the long run. So I'm going to go ahead and I'm going to do two congruent sides first. Doesn't matter which one you do first. So our isosceles triangle is that big triangle there, AWQ. They tell us what the base is. The base is WQ. It's important that they tell us that because the congruent sides are the ones that are not the base. So WQ of your three sides in that big triangle is the one that will not be congruent. So for our statement, we're going to have WA congruent to AQ. We said something was congruent in our proof, so we'll go ahead and mark it up in our picture with our tick marks. And we'll go right ahead and do our next isosceles triangle one. We've got isosceles triangle implies two congruent base angles. Now there's two ways we can identify where those base angles are. If we think of the big triangle, they're the angles that are across from those congruent sides, or they're the angles that are at the end of the base. So the base is WQ, so the base angles should be angle W and angle Q. And we can name those with a single letter because they are the only angles happening there. If you preferred to name them with three letters, you could. Just W and Q should be the middle letters when you're naming them, or you're always welcome to number them as long as you can number it clearly in your picture. We said something was congruent in our proof, so we can go ahead and mark it up in our picture. We'll put our arcs for angle W and angle Q, showing that they are congruent. So we've used that first given as much as we can. We'll go on to that second given. We've got a midpoint, so automatically we should be thinking midpoint implies two congruent segments. If M is right in the middle of W and Q, that means that our congruent segment should be WM congruent to MQ. And we'll go ahead and mark that up in our picture. We have three sets of things. Remember, the two that don't work are side, side angle and angle, angle, angle. And the other combos do work. We just have to identify what they are. We have two sides and we have the angle that's in between. So that would be side angle side, congruent to side angle side. And our statement is just what we wanted to prove. Now there was one other way we could have done this proof. We could have not done our two congruent base angles and then done reflexive property and had side, side, side. However, an error some people tend to make is they'll maybe not do the congruent sides from the isosceles triangle and do reflexive, but then you have side, side angle, and that's one that doesn't work. So you got to make sure it is one that works. Our basic rigid motion, we would have a reflection here. So reflect, triangle, and I'm going to pick WAM. Over AM. So the other one we're going to look at as a group is number 7. So again, on your separate sheet of paper, you can go ahead and do your statements, reasons, and givens. So in this case, we've got a bunch of different triangles, so it's not obvious which ones we want. So before we start marking things up, let's identify those triangles we want to get congruent. We've got RQY, which is this one here. And we've got TQX, which is that angle there. Now, because they overlap, we should redraw them separately so it is easier to mark up. And again, please be doing that on your paper, redrawing them so it's easier to mark up. All right, we were given some things congruent in the given, so let's mark those up. We got QX, so we'll put a single mark on that. And we've got QY, I'll put a single mark on that in both pictures. And then we got XR and YT. So note, XR we have here, YT is here, but in our separate pictures, those are not sides. So we should be suspicious. Why did they give us XR congruent to YT? Well, notice XR is too short to be a side in a triangle. XR is basically about here in that red triangle. And YT is roughly about here. So they're too short to be the side in a triangle. Well, if something's too short for the side in the triangle, we would want to add on to it. So we're going to do our addition postulate. And we're going to take XR and add on QX. And that's congruent to, XR would be congruent to YT plus QY. And then we always want to rename. If we put together XR and QX, that's going to give us QR for a single segment. And that's congruent to, if you take YT and QY, that's going to give us QT. And now that we've said that's congruent in our proof, we can mark it in our picture. In our big picture, I would have to mark that with a bracket because it's spanning over multiple parts. So notice in our pictures we drew to the side, there's only two things marked up. We still need something else. And we're going to use something here that the reason we've used before, but the statement is not something we've seen yet. Notice when I traced the original red and blue triangles, they both trace the entire angle Q. We've only seen shared sides up to this point. This is a shared angle. So when something's shared, we use reflexive property. So we're going to go ahead and use reflexive property. And we're going to have angle Q congruent to angle Q. In this unit, mainly you see reflexive property for sides. This again is the only time we've seen it with the angle. We will see in our similar triangle proof unit later in the year, we'll do reflexive property for angles a whole bunch. So we just said Q is congruent to Q, so that's that angle and that angle. Notice you have two sides with an angle in between, so that's going to be side angle side, congruent to side angle side. And our statement is just the triangles that we wanted to get congruent. For our basic rigid motion, we would need a reflection. So we would reflect, pick either triangle you want. I'm going to take triangle RQY. And the line we want to reflect over is not actually drawn there, so we got to describe it as the perpendicular bisector of something. So we're going to reflect triangle RQY over the perpendicular bisector of, and it's got to be of a line. So probably the most common thing people would say is RT. You could also say XY. Either of those would be all right. All right, so here's what you are going to do the rest of the period. First off, you're going to take out your proof reason study card. And to yourself, just in your head, you're going to quiz yourself, folding back each of the tabs, and you've got to keep quizzing yourself until you can get them all the way correct going through once. If you can't get it the first time through, keep doing it, because if you don't have those proof reasons memorized, there's no hope on the test. So that's the first order of business. Make sure you can get through that entire proof reason sheet before you go on to the homework ones. Once you can do that, then on your separate sheet of paper, you're going to be doing questions 3 and 9 from the same pages in the review, page 35 and 36. Make sure to bring in a charged Chromebook next class for you to be working on the proofs that are going to be on a Jamboard. And other than that, have a great rest of your day.